Okay, so let's look at the final piece of the basics of Python. The final data types, really. The final data types, what we looked at so far are strings, integers, floating point numbers. These are very basic pieces of data. In Python, you can also have collections, because obviously you need arrays and vectors and those kind of things where you can put lots of data together, identical data together, and then access each item individually from that. So collections are very useful. So we're going to look at collections, and we're going to look at how to iterate over these collections. So let's first take a look at collections. So the most important type of collection in Python is a list. Lists are sequential, ordered, mutable collections. And I'll explain what each of those things mean. Sequential is pretty straightforward. The idea is that the sequence of elements matters. Now, Python doesn't care whether it matters or not. It matters to you, the programmer. So for example, if I'm looking at a price series, and I'm looking at the prices of, say, a stock, then it matters to me that on day one, the price was 24.2. On day 2, the price was 25.1. On day 3, it was 23.7. So day 0, day 1, day 2, etc. So what this says is there's an ordering on my data. And that's what the word sequential and ordered means, right? The data is sequential. The order matters. It matters that this price 24.2 is before this price 25.1. So that's the first point that we have to deal with in this stuff here. So let's take a look at some examples. So we have here a list, and the way Python recognizes the list is if it sees a square bracket at the beginning and the end of something. So the moment it sees a square bracket, it says, hey, that's a list, as long as it's not an indexing operator. So the difference, say, between x5 and x equals 5 is that in this case, this is an index, and this is a list. And contextually, Python figures that out. It says, hey, wait a sec, there's an equal sign and then square bracket, so that's a list. And it says, oh, hey, wait a second, there's an identifier x followed by this, therefore that must be an indexing operator. So here we see several examples of lists. So we've got a list of names, which is John, Jack, Jill, Joan, a list of tickers, Apple, Ions, GE, DB, a list of natural numbers, 1, 2, 3, 4, 5, 6, 7, and a long list that contains lists inside it. So the idea here is that a list can actually contain lists, and in Python, there's no requirement that a list contain objects of the same type. There's no requirement that they actually be sequential in your mind. Python will treat them as sequential, but that doesn't really matter. So here, if you look at this long list, and we count the number of elements over here, we see there's an integer, 1. Then we have a list A, B, B, C, which contains a list. So that's a second element. Then we have the integer 43, and then we have a string, too many cooks spoil the broth. So the long list here actually contains only 4 elements, right? One of the elements is a complex element because it contains A, B, and it contains a list. However, the number of, as far as long list is concerned, if you asked it how many elements do you have, it'll say I have 4 elements. So those are the kind of basic examples of lists. So let's look on and see what kind of operations we can do on lists. And for this, let's go and see them in practice. So if you want to create a list, we can create lists in multiple ways. We could just create a list by specifying the values. We could create a list by giving the list, calling the list function. What this is, create an empty list. Or we can create an empty list by just specifying the square brackets, and we would get an empty list that way. Either way will work. So we get this stuff. And note now we have a list here that has 4 elements, that's x, and a list here that has no elements, that's y. We can add items to a list. The way to add items to a list is to use a function called append. There are other ways, we'll see them briefly, but the append is the most common function. And what append does is it takes an item and adds it to the back of the list. So in our example here, we start with an empty list, and then we append a 1, and then we append a 2. So we start with the empty list, we append a 1, and we get a list with 1 in it, and then we append a 2, and we get a list with 1 and 2 in it. So append, notice that, just make sure that you always remember an append takes only one thing inside it. The append function has only one argument, and whatever that value of that argument is, that will get appended. So if you append, for example, if you're trying to append a list to this thing, if I did x equals 2, 3, and I did x dot append 4, what's going to happen? Well, it's going to say, hey, I have a list with 2 and 3 in it, 2 elements. I'm appending a new element, and the element I'm appending is the list 4. So I get, I should actually print that. I get a list that contains 2, 3, and the list 4. Okay, so you have to watch out for that. So it takes only one argument, and that argument will be as is appended to the back of the list. You can insert too. Inserting is not usually a great idea, though it doesn't matter too much in lists. So if I have the list x, which we now know contains 2, 3, and the list 4, and I want to insert the word half in the 0th place, then what's going to happen is that currently in the 0th part of my list I have a 2, so everything is going to move up, and I'm going to get a list that contains half and then 2, 3, and the list 4. I can also extend the list. Extending the list is slightly different. When you extend a list, you're going to give the argument you're going to give is another list. And what Python will do is it will unpack the list and add the items to the back of the list that you're extending. And so here we have a list x, which is empty, and we extend it by a list 1, 2, 3. So rather than getting the list 1, 2, 3 inside it, we get the entire list contains 1, 2, 3. Notice the difference between this and append. If I did x equals list and x dot append 1, 2, 3, it's going to be slightly different, right? You ready? Yeah. So here what I'm getting is the list that contains one element, which is the list 1, 2, 3. Here I'm getting a list that contains 3 elements, the integers 1, 2, 3. That's the difference, because in the case of extend, it unpacked the elements. In the case of append, it just added the whole object itself into the back of the list. Since it's sequential, just like in strings, we can index and slice them. So this is, exactly like strings. If you take the length of x, it's going to count the number of elements. If you take x and say, give me element number 3, it's going to give you element number 3, which is 5. And if you take slice it by 2, 5, just like in strings, you're going to get the elements in location 2, that is the 2, location 3, location 4, but not in location 5. So you get 2, 5, and 3. And then if you do x -1, it goes to the back and does that, gives the last element 32. And of course, you can inverse the list by doing x : -1, just like we did with strings before. You can remove items from a list, and there are 2 ways of doing that. You can use pop to remove a specific location from an item from a specific location, and you can use remove to remove an item with a specific value from the list. So here we have x.pop, and what this will do is it will remove the last item, 32, from the list. x.pop3 will remove whatever item is in location 3, which in this case is the number 5, 0, 1, 2, 3, location 5. And then x.remove7 will remove the first 7 that it finds. In this case, we have only 1 7, but if you had more than 1 7, it will just remove the first 7. So we get in the end, what we get is the 32 removed, followed by the 5 removed, this 5 gone, and then the 7 gone. Right? Those 3 things there. As with everything, you have to be careful that you don't try to remove something that is not in the list or access something that is not in the list. So if I want to remove the number 20 from x, and I do that, I get a value error because 20 is not there. If I try to pop the 20th location, I'm going to get a value error, index error, because there is no location 20 in the list.